Alright, so you're starting a section on rational expressions, which is essentially algebraic fractions. So I want to begin by just doing a little review of rational numbers and show you how that connects to what we're about to do. A rational number, you'll remember, is a number that can be written in the form a over b, where a and b are integers and b is not 0. So for example, decimal 5 is a rational number because it can be written as an integer divided by an integer. 0.3 repeating is rational because it can be written as an integer over an integer. And you'll remember that any terminating or repeating decimal is rational because it can be written in the form a over b, where a and b are integers and b is not 0. Now, the division by 0, I think, again, most of us are familiar that we can't divide by 0, but just a little bit of a refresher as to why that is. And this all goes back to how we define division. When we say 10 divided by 2 is something, we know the answer to that because division comes from multiplication. We can write a division statement, or think of our division statement as 2 times something has to equal 10. And we think about that and we see that's 5, so we therefore know that this is 5. So when I come to 0 divided by 2 is something, again, I know that that means that 2 times the something must give me this, 0. And again, when I think about that, 2 times what is 0? I realize the answer is 0, and so this answer is 0. Alright, what happens if I go 2 divided by 0? Okay, so again, we can write this in terms of multiplication. We know that 0 times something would have to give us 2. So 0 times what is 2? Nothing. There is no value. And so that's why we know or say that a number divided by 0 is undefined. There is no value. Just one other variation on this. What if we had 0 divided by 0? So that would mean that 0 times something would have to equal 0. Well, 0 times anything can be 0. So actually this value could be any value. Okay? And so we say, since it's not one fixed value, like most things are when we try to figure them out, we say that this too is undefined. Okay? So division by 0, not possible. So after reviewing rational numbers, we're now going to look at the definition of a rational expression, which is going to sound similar. A rational expression is of the form f of x divided by g of x, where f of x and g of x are polynomials, and the denominator g of x is not 0. Alright, now just in case you need a review of what polynomials are, let's just flip over to this screen. And a polynomial can be written in this form. A real number x to a power plus another real number x to the power 1 less than that plus a real number x to the 1 power less than that. And the powers all go down by a value of 1 at a time. So we might start with x to the 10th plus something x to the 9th plus something x to the 8th plus something x squared eventually plus something x plus something, where that's just a number, a constant. Okay? So anything like these are polynomials. X squared plus 4x plus 2. The main thing here is that the exponents must be whole numbers. No negative exponents, no fractions, just positive numbers, whole numbers. So the square root of x is not polynomial because that could be thought of as x to the 1/2. Okay? So back to our definition of rational expression, anytime I have a polynomial, so for example x plus 4 divided by another polynomial x squared minus 2x minus 1, this new expression is a rational expression. Now with a rational expression, as with any expression, if you take specific values of x, for example if I said that x is 1 and I substituted this into the expression, I would get a specific number. In this case, I would get 5 over negative 2. Alright, so different values of x produce different specific values for the rational expression. The thing we've got to be concerned about is that we don't insert values of x which cause the denominator to be 0, because we know we can't divide by 0. So we're going to look at some expressions here, and we're going to look at for what we call undefined or non-permissible values of the variable. So let's look at this rational expression. Are there any values of x or y, if we substitute it in, would cause the denominator to become 0? Well, since x and y are multiplied at the bottom, if either one of them was 0, we'd have a problem. So our restricted values are as follows. We can substitute any values of x and y into this expression to get a number, except for these. If I had 2 plus x over x minus 1. Okay, we have x minus 1, so what would cause this to be 0? If x minus 1 was 0, we'd have a problem. So we're saying that x can't be 1. That's my non-permissible value. Alright, another rational expression. This one's a little bit more complicated. Are there any values of x that we can't substitute in? Well, we don't want values of x that make the denominator 0. We don't want that to be 0. Alright, so what we're going to do is we're going to factor this. This is a quadratic expression. So if I factor that, x minus 3 times x plus 1. Let's just think about the values that would make it 0, because those are the ones we don't want. Alright, so we got two factors equaling 0. If x was 3, that would cause this bracket to be 0, and that would mean that 0 times the other bracket would be 0. So we don't want x to be 3, and we don't want x to be negative 1.